You ever just stop and think about how our world runs on this perfect schedule? I mean, the sun rises and sets like clockwork. The seasons change in this predictable rhythm. Even the tides seem to know exactly when to show up. It's like this massive, beautiful cosmic dance. And today, we're going to figure out the steps.
So, let's really get into it. The big question is just, why? What are the invisible forces, the grand design that makes everything so unbelievably predictable? Well, to get to the bottom of it, we actually have to go way back in time, to humanity's first real attempt to draw a map of the universe.
You know, for early observers, the answer seemed pretty obvious. Just imagine, you're standing there, watching the sun, the moon, and all the stars march across the sky every single day. The most logical conclusion? Everything must be revolving around us, around Earth.
And that idea has a name, the geocentric model. You got geo for Earth, centric for center. Simple, right? It's the theory that a stationary Earth sits right at the heart of everything, and the whole universe just circles around us. And you know what? For thousands of years, this model made total sense. It perfectly explained what people saw with their own two eyes day in and day out.
But here's the thing about science. It's all about the evidence, not just what seems right. And as our observations got better and more precise, that old model just started to fall apart. It was time for a truly revolutionary idea, one that would completely shift our place in the cosmos.
And that's where the heliocentric model comes in. Helio for sun. Astronomers like Copernicus proposed this radical idea. What if the sun is at the center and Earth is just another planet orbiting it? I mean, what a world-changing, mind-bending concept that was.
So, let's just let that sink in for a second. The entire shift was going from believing we were the special, stationary center of absolutely everything to realizing we're on a moving planet, just circling a star like everyone else. This wasn't just a small tweak in an astronomy textbook, it was a profound change in how humanity saw itself in the universe.
And you got to understand, this wasn't just some wild guess. Astronomers like Galileo, using brand new technology like the telescope, started gathering evidence that the old geocentric model simply could not explain. This new data wasn't just suggesting a new idea, it was proving the old one wrong and pointing directly to this new, sun-centered view.
All right, so with this new, correct model in hand, we can finally unlock the secrets behind our planet's predictable rhythms. It all comes down to this beautiful three-body dance between the sun, the Earth, and our moon.
And what's so cool about this is how simple it is to demonstrate. Seriously, we don't need a supercomputer or a particle accelerator. All we really need to understand this cosmic dance is a torch to act as our sun and a couple of balls to be the Earth and moon.
Okay, let's start with the most basic cycle of all, day and night. Earth is spinning on its axis, kind of like a top, once every 24 hours. Now, if our torch is the sun, you can see that as our Earth ball rotates, one side gets lit up, that's daytime. The other side is in darkness, and that's nighttime. It's that simple, steady spin that creates the most fundamental rhythm of our lives.
Now, what about the seasons? This one trips a lot of people up. It's a common myth that summer happens when the Earth is closer to the sun. But nope, that's not it. The real secret is Earth's tilt. Our planet is tilted on its axis. So, as we orbit the sun, that tilt means one half of the planet is angled to get more direct, concentrated sunlight. Think of it like a flashlight shining straight down on a spot. More direct light means more heat, and that's what brings us summer. And the moon? The different shapes or phases we see, they aren't caused by the Earth's shadow. It's really just our changing point of view. See, the moon doesn't make its own light, it's just reflecting sunlight. As it orbits us, we see different angles of its sunlit half. When we can see the entire lit up side, boom, that's a full moon. When we see none of it, that's a new moon.
And this whole cosmic dance, it has an invisible force driving it, gravity. The moon's gravitational pull is actually strong enough to tug on Earth's oceans, creating a bulge of water on the side facing it and on the side opposite it. As our planet spins, we pass through these bulges, and we experience that as high and low tides. The sun helps out a little too, but our moon is the main choreographer of the tides.
And then, every so often, the dancers line up absolutely perfectly. When the moon passes directly between the sun and Earth, it casts a shadow on us and we get a spectacular solar eclipse. And when the Earth passes right between the sun and moon, our shadow falls on the moon, giving us a beautiful lunar eclipse. These are probably the most dramatic moments of the entire cosmic clockwork.
So we've gone from just looking up at the sky to building this powerful model that explains our world. But why does having an accurate model like this actually matter so much?
What's the big deal?
Well, the power of a good scientific model isn't just that it's correct, it's powerful because it explains what we see and it lets us make these stunningly accurate predictions. I mean, we can time an eclipse down to the second, years in advance. But most importantly, it reminds us that science is a process. Our understanding has to change when new evidence comes along. These models are our best, constantly evolving tools for making sense of this incredible universe.
And that kind of leaves us with one last thought. We went from an Earth-centered model to a Sun-centered one. That was a massive, revolutionary change, all driven by new evidence. So the real question for us today is, what discovery is waiting out there that might just fundamentally change our understanding of the universe all over again?